In this video, we will practice solving quadratic equations using our three main methods, using square roots, completing the square, and using the quadratic formula. The one we're not doing right now is by factoring, which is kind of our favorite way to do it. But these are the more exotic methods of solving a quadratic equation. By the way, a quadratic equation is just an equation that has degree 2, where it's going to be squared. Anyway, number 18 would be a good one to solve using square roots, because what I can do is try to get the parentheses by itself. Now, a lot of kids will look at this and they'll want to like distribute or something. They want to do something else besides what they're supposed to do. And what I usually tell them is, wait a minute, imagine that this was not parentheses. Say this was a q, like 2q squared minus 17 is equal to 1. What would you do first? If I took away the distributive property that you were tempted to do, what would you do? And usually if I give it to them like this, then they say, oh, well, let's add 17 to both sides. That's what they would do. And then I say, look, this is going to be the same thing. Just treat the parentheses like a q. All right? So we're going to add 17 to both sides first. But let's go ahead and see what else we would do. If I have 2q squared, now I'd have equal 18. Again, I don't want to distribute. So if I look at this like a q, what would I do next if I take distributing away? Most kids will tell me, well, I would divide by 2. All right, and that will give you q squared is equal to 9. So look what we did. We added 17 to both sides and we divided by 2. We're going to do the same thing with this problem. Basically, treat the parentheses like it was a q. And in that case, it will be easy to see that I will add 17 to both sides as you just saw. Okay, and so that's going to give me 2 times x plus 5 squared is equal to 18. And no, I'm still not going to distribute. Instead, I will divide both sides by 2. You can't distribute when there's an exponent here. All right, there's no property that allows you to distribute. In fact, order of operations, we have multiplication and we have a power. All right, please excuse my dear Aunt Sally. Which comes first, multiplication or exponents? Exponents come first, so you can't sit here and multiply before you've done the power. So instead, we're just going to divide both sides by 2. All right, so those will cancel out, and that will leave you with x plus 5 squared is equal to 9. Now, we will unsquare this using square root. So if I take the square root of both sides, now anytime I take the square root of both sides, the solution side is going to be plus or minus. So that's going to give me x plus 5 is equal to plus or minus 3, because that's a perfect square. Finally, I need to subtract 5 from both sides. Now, do not try to just do 3 minus 5. All right, this is not a single number. This is two separate numbers, a positive 3 and a negative 3. So what I always suggest is, for right this second, let's just put the negative 5 in the front right here. So I'm going to have negative 5 plus or minus 3. Now we can deal with it. All right, so this means two things. It means negative 5 plus 3 or negative 5 minus 3. That's the plus or minus 3, plus or minus 3. So now I will get my two different answers. Negative 5 plus 3, that's going to be negative 2. Negative 5 minus 3 is negative 8. Notice it's not just positive, negative, the same number. Alright, so that is how you solve by using square roots. Alright, now let's move on. So for number 19, we're going to solve this one by completing the square. Okay, so here's how that works. Completing the square involves having a very special number right here. And we get that special number by doing half the middle squared. So 25 is not the correct number. So let's start off by subtracting 25 from both sides. Just move it out of the way. Alright, so that's going to leave us with x squared plus 6x. Now just leave a space right here where you moved this away. Equals negative 25. Alright, we've just moved that over. Now like I said, the special number that goes right here is supposed to be half of the middle squared. So half of 6 is 3. 3 squared is 9. So I'm going to put a 9 here. Now you got to be very careful. As soon as you add a 9 on the left side, you have to simultaneously add a 9 to the right hand side to keep the balance. Okay, so now the point of this, by picking this special number, this trinomial will always factor as the same thing twice. Alright, meanwhile over here we get negative 16. Okay, but this is going to factor as x plus 3 times x plus 3. Right, 3 times 3 is 9. And inner plus outer equals middle. 3x plus 3x is, excuse me, 6x. So, because it's the same thing twice, we can write this as x plus 3 squared is equal to negative 16. Now, remember on the previous problem when we solved by square roots? Well, we will still do that. We will end up solving by square roots now, because we'll take the square root of both sides. Don't forget this will be plus or minus when we take the square root of both sides. So this is going to be x plus 3 because we've unsquared it. See that negative under the radical? You know that's going to be I, right? But then the square root of 16 is 4, so this is going to be 4i. So plus or minus 4i. Now we need to subtract 3 from both sides. And I will put it in the front. So that's going to give us x equals negative 3 plus or minus 4i. Alright, and that is how you solve by completing the square. Okay, let's move on to number 20. Solving using the quadratic formula. Now remember, the quadratic formula, we use it to solve equations that are of the form ax squared plus bx plus c equals 0. Given an equation in this form, we know that x will be equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And in my head I'm going opposite of b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. My poor daughter knew the quadratic formula when she was 7 because of that song. So, if you have trouble remembering the quadratic formula, practice the song and you'll be good. Anyway, I put this part under the radical in pink because that is special. We call it the discriminant. Alright, learn how to speak math. It's a language. And it has its own vocabulary. It's the discriminant. It tells us things. Always calculate the discriminant first. So anyway, for this problem, you see your A, your B, and your C. You know B is 1. So when I begin to do the problem, I'm going to start off with this whole, why did I put X again? Opposite of B would be -1, plus or minus the square root. 2a is 4, all right, all over 2a, that's all over 4. But anyway, the discriminant, b squared minus 4ac, well, that's 1 squared minus 4 times 2 times -15. All right, there's my discriminant. Always calculate the discriminant first. So let's see, 1 squared minus 4 times 2 times -15. All right, obviously 1 squared is just 1, so you could have just put 1. But anyway, minus 4 times 2 times -15. Okay, that is 121. That's my discriminant. Okay, so that's going to give me -1 plus or minus the square root of 121. Okay, now the square root of 121 is 11. All right, 121 is 11 squared. So this is going to be -1 plus or minus 11 over 4. Okay, so that means -1 plus 11 over 4, or -1 minus 11 over 4, plus or minus 11, plus or minus 11. -1 plus 11 is 10 over 4. -1 minus 11 is -12 over 4. 10 over 4 reduces down to 5 over 2. -12 over 4 is 3. All right, and that is how you solve a quadratic equation using the quadratic formula.